I'm Anil Kumar, and this is a very important video to understand solution of quadratic functions. The topic here is x-intercepts of quadratic functions, and the question which we are working on is how to find x-intercept of a quadratic function. It's a very general question. Normally, when we say x-intercepts, we could have replaced this term with terms like let me write down for you. Terms like how to find real solutions, or real zeros. Many times we do not write the word real, right? We do not write the word real since we are working in the domain of real numbers. We say x belongs to real numbers in general. So we are not working with complex numbers, and therefore we do not normally write real, right? So real is by default understood anyway. But when we say find x-intercepts, it means we are working with real numbers and not imaginary numbers. That I hope that point is very clear. It's very important to understand. Now let's move forward. The question is how to find x-intercept of a quadratic function. Now, this is an open question. Now, quadratic functions could be given in many different forms, right? We could have quadratic functions in factor form. We could have them in standard form, for example, right? So there are different forms in which we could get quadratic functions. Now, the approach is going to be different depending on the form itself. Let's take a few examples for factor form, right? So let us say y equals to x plus 1 times x minus 3 is the equation. Now finding x-intercept really means that wherever the graph crosses the x-axis, at that point we know at x-intercept y is equals to 0, right? So we should make y equals to 0. So I'll write 0 equals to x plus 1 times x minus 3. Now since it is in factored form, we know we can get 0 if either one of these factors is 0. So if x plus 1 is 0, then the value of x should be what? Well, in that case, x equals to minus 1. Well, x minus 3 is 0 at x equals to 3. So we have two solutions. One is x equals to minus 1 and the other one is x equals to 3. And therefore we can say the x-intercepts are at x equals to minus 1 and x equals to 3, right? So when given in factored form, it's kind of simple, right? Let me take another example. Sometimes we could have something like this. Y equals to, let us say 2x squared x minus 1. Now can you write down the solution for this one? Well, simple. X minus 1 could be 0 for x equals to 1, and 2x squared could be 0 for x equals to 0. So we have two x-intercepts, correct? Now 1 and 0, correct? So we may get x-intercepts like this. There are times when you may not have any solution, and that is kind of interesting to know. Let me write y equals to x squared plus 1. As you can see, well, I've not even written in factored form since this does not really have any real factors, right? But if you are given an equation like this is never 0, so there could be situations where you may not get any x-intercept. It's important to note. Now let's move forward and understand how to find solutions in standard form. This is one of those standard forms you can consider, right? Not a factored form, of course. Now let's take up a general standard form and then see how to find the solution or the x-intercepts. So I like to take two examples here, so I'll conserve on some space. We'll begin with one example with, let us say we have x squared plus 2x minus 1. Let us say a simple equation, kind of like this. Now to find the x-intercept, we have to equate y to 0. So we get 0 equals to x squared plus 2x minus 1. Now in this situation, what we can do is that we can do completing the squares and then solve for x. That is the best way to do. To complete the squares, we need to add and subtract half of this number square, right? So we'll do x square plus 2x is already there. Half of 2 is 1. So we'll add 1 square and we'll subtract 1 square. And we already have minus 1, correct? As you know, these three terms form a perfect square, right? So we could write this as equal to x plus from here, 1 from there, whole square, minus 1 is minus 2, right? That is equals to 0. Now you can solve for x. Bringing 2 to this side gives you 2 equals to x plus 1 whole square. Now when you square root it, we get plus minus square root of 2, right? Is x plus 1, and solving this gives you two solutions, right? And that gives you two solutions. X is equals to, bringing 1 to this side, minus 1 plus minus square root of 2. So these are the two x-intercepts for the given equation. Do you see that? So that is how, from the standard form, we can actually get the solution, right? Now this equation was not factorable, and therefore we did completing the squares. So one of the method is complete squares. Which we did at this stage, right? To solve for x-intercept, right? If it is possible to factor, in that case, we should factor and then do the needful, right? So for example, if I have another equation which is, let us say y equals to x squared plus 2x. Now instead of minus 1, if I would have taken plus 1, I would have factored directly and did the needful. Do you understand, right? So we could have done it, right? Now let me take another example. Now we know 4 times 2 is 8 and their difference, so we'll take minus 8. Okay, so I made up this equation which can easily be factored. Here we are looking for product of two terms as minus 8 and sum of two terms as plus 2, right? So we'll just factor this. The two terms could be 4 and minus 2, right? When you multiply them, you get negative 8. When you add them, you get plus 2. So we could write this equation as y equals to x plus 4 times x minus 2. Once you have factored, you can apply the techniques which you have already learned. Equate each factor to 0. We want to find x-intercept, right? We need to find x-intercept. That means y equals to 0. So we'll equate 0 and write the factored form of the equation, right? Now equate each factor to 0. If I do x plus 4 equals to 0, I get x equals to minus 4. If I do x minus 2 equals to 0, I get x equals to 2. So our answer will be, we have x-intercepts at x equals to minus 4 and 2. Do you get the idea, right? So that is how we can find x-intercepts for a quadratic function, right? I hope this video really helps you to take different types of examples and do it on yourself. So try some questions from the book. We have few more solid examples for you to practice. Thank you and all the best.